Good morning, everyone. Welcome back to Bio-Rad. So yesterday we had a keynote from the president of our LSG group, our life sciences group. And today we're honored to have Shakila Pothini, who is on the other side of the business, which is our clinical diagnostics group. So by way of introduction, Shakila is our VP of software within CDG. She's an AI expert and actually teaches courses on bioinformatics. So thrilled to have her here and kind of share a little deeper on our clinical diagnostics group. And her talk is the Lab OS we've been waiting for, AI agents, MCP, and ASM. So
thank you, Kashif. Really excited to be here. This is just a strategic exercise we are looking at because, as Kashif said, I head the software for clinical diagnostic group. We have instruments that were built probably 20 years back, sitting in the lab and running as a workhorse. So really thinking about what is the best approach to have these systems, and especially legacy systems that's existing in the lab to kind of match to the existing technologies and how we can have that interoperability, especially given that AI needs a lot of data. So that's kind of the context, and it's more of a strategic path we are looking at and hoping to do some hackathons to get this implemented and rolled out. So I would love to get your feedback, what works, what doesn't work, and then we can have like a brainstorming session around it. You have the oh, it's right here? Yep. Oh, okay.
Bitte noch 20 Euro haben. Ich hätte nur 5 Euro gegeben.
Okay, so what's the current reality? Absolutely, lab data is exploding, right? But insights are trapped in silos. You have different systems. I can't even get my same instruments connected in the lab to share the data. It's really complicated. I'm preaching to the choir here. Scientists spend more time on data cleanup than discovery. And this is an important point I want to highlight. Everyone talks about AI models, building solutions, agentic AI, but 70% of the time is actually spent in data acquisition, data cleaning. Actually building the model, it's interesting. I was teaching CNNs yesterday. I had a class for 3 hours. The line to build a CNN model to classify a breast tumor image is actually only 20 lines. But the time it takes to get the images annotated, get the metadata, that is the one that takes a lot of time. And today, even though the technology has gone far, we don't have the practices and process and data uniformity across these different organizations and labs. Yes, we are missing metadata, not just in the labs, even within my R&D organization, we have like R&D instruments running in Poland and running in Israel and running in US. And then there is no like a standardized way of collecting all that data. Valuable results are inaccessible. AI and automation efforts are stalling because we don't have this data. Cross-functional and multi-site collaboration is becoming really slow. This is the reality in many of the organizations and in many of the labs today. Okay, what needs to change from isolated systems to interoperable systems, from manual handoffs to autonomous workflows, data that is inaccessible all organizations should start thinking about how do you make your data ready for AI, right? Like that's a cultural shift. It's not about collecting the data, it's about making the data intelligent that you can use it ahead. And why is it important? And I think I kind of spoke about this before. We are like 30% of our code today is written with AI, right? Like that's the amount of advancement we have made with AI, but we're still struggling with the data and interpretability and getting insights from that data. So this is where Allotrope is already leading the way, right? There are standards, there are protocols, there are domain and data models that could be used to standardize how the data comes from different instruments. It's intelligent transformation. We have these standards, which helps us to go from silos to interoperable. Data can flow across instruments, shared ontology, shared understanding, faster R&D. But what is the challenge we face in the lab? We have this, it's great, but we have a challenge. What is the challenge? Why do we still struggle with this? Why do we still have labs that doesn't standardize data sets? Why do we still have instrument and device manufacturers who do not comply with these data standards, right? There are data standards. ASM provides a clear path to standardize the data, but most instruments are non-compliant. Vendors are not incentivized to do it, and rightfully so. I am playing the role of a vendor here, right? I have clinical diagnostic instruments sitting in the lab. 20 years back, we can't even like do a simple upgrade because we're trying to struggle with the code base and getting up to speed on that. So there is a true challenge in the labs today with the instruments, even for vendors, to go back and retrofit their existing platforms for open standards. It's not easy to do it. So you have fragmented results, right? Stalled AI ML pipelines. Yep, I think we have brittle code, lot of custom integration pipeline that comes right today. If you look at, there are a gazillion number of middlewares trying to consolidate all these data standards and data sets together and get some sense and interpretability. That is a nightmare. It is a complete waste of time given in the world of where we are with AI and automation. We actually write like custom transformation pipeline for every device, which is not a small project. It takes a lot of time for us to build these. So what am I proposing? Again, this is a thought exercise. This is something we've been playing with, and we want to roll this out and see how it works. Model context protocol servers and agents can change the game. So what are we talking about here? Let's take different instrument types that exist in the lab. We don't go change the instrument. We let the instrument generate the file formats the way they can. What we have is a model context protocol server, which is a part of, I will talk about a little bit of what MCP servers are. It's a standardization that many companies like Anthropic and Microsoft and all of them are proposing on how AI agents should work and how you can access data across different platforms with MCP protocol server. So there would be an MCP protocol server that will convert any instrument data to an ASM format or any standardization format we have. And then there will be agents that will pull these data from different MCP server and perform meaningful actions. So imagine an MCP server connected to a bedside monitor, a lab system, a document store. Each server will convert data into a structured, semantically understood format. And then you have AI agents that will pull all of these MCP servers looking for new data sets as they come and merge patient vitals, lab results, and notes into a unified snapshot. And applies a sepsis risk model. I'm working through a use case, right? And detects early sign of organ failure before symptoms appear. So this is the use case. This is not technically difficult and it's not intrusive because you're not going back and fixing the instrument. The instrument produces the same file format, right? But you are having adapters or MCP servers in between that will do the job for you, and then the agents will work with the MCP server to get it. So what is an MCP server for people, like if you are hearing it for the first time, it's, like you sleep and you get up and there's a new terminology for AI, and like you get like, you get like information exhaustion today. It is really hard. But this is taking a lot of momentum, right? Like a lot of like Slack, GitHub, Microsoft, a lot of companies are building MCP servers around their enterprise platforms. So MCP is an open standard designated to facilitate connection between AI agents and various data sources. It's a standard. You can take that standard and you can implement it. So this is an example architecture that you have, right? So what does an MCP server have? It's not just an API. It has an embedded AI capabilities within it. So this would be, in our case, every instrument, this could be an instrument, this could be a EHR, it could be any of this. You build multiple MCP servers and have the MCP client access the server for the data in the either JSON format or ASM format through HTTP or WebSockets or whatever protocol you want, right? But the way MCP servers are called today, they're called USB-C of AI. So you can plug and play MCP servers to any of your system and get your data out of that real time. So let's take a look at our use case we were talking about. Like, what will the MCP server have in the use case that I walked through? You would have a data trigger, which continuously monitors the input in any of these formats. And as soon as it triggers the file, it's going to call AI parsing and mapping, which is driven by LLM. You could use Claude, you could use ChatGPT 4o, whichever LLM works for you. The parsing and mapping will take the raw data from the instruments or devices, input the schema, and map the field to the ontologies that's standardized. So that would be a little AI pipeline that would be running and doing the transformation. You could also do metadata enrichment, where if you understand who the user was, what the timestamp is, what the location is, you can add this metadata into your standardized data format, right? This could also be another LLM agent that parses the CSV file, looks for metadata, and converts it into your standardized semantic format, and provide a secure API access with authentication and access control for any of the clients to access this data. So this is you building you could have multiple types of instruments, right? So you could build MCP servers for each type of the instrument, and every instrument MCP server can do this. And they are enriched by AI models, and you can pick and choose. The structure is such that you can pick and choose which AI model works best, because sometimes GPT-4o may not do a good job. You want Bio-GPT, or you want something that's more trained with the terminologies and the domain we are in. So yeah, just a summary, MCP server could have these modules running inside it, which are AI-based modules. Now that you have these MCP servers, what is the role of agents, right? Agents are a little different from AI models. AI models predict, agents act. Agents are like little things that go around and bring all these models together and take an action and come up with an insight. So agents could hold the MCP server, check for new patient data every 2 minutes, merge the data snapshot from different places, bring the metadata in, bring the patient data, bring the radiologist, bring the clinical notes, everything together, analyze vital trends. It could use LSTM, right, models to detect the time-based anomalies. It could apply risk scoring. You could use XGBoost model for that. It will basically say probability of sepsis. You could extract the clinical notes. Again, the agent can run the GPT model to extract the clinical notes and take an action, which would be alert a clinician, update the dashboard, and trigger the retest. So that would be an overall end-to-end workflow where you have agents sitting, working with MCP servers. MCP servers acts as a layer in between the legacy old instruments. When I say old instruments, I'm not talking about 20 years. Even instruments that were built 5 years back, doesn't even produce data in JSON format, right? Like they have their proprietary format. So this could be a solution that we are thinking that we could bring up to speed on all the other instruments that we already have in the lab, on how we can standardize and connect data. So just the last slide I have, and I'm hoping to have some input feedback. Does it make sense or does it not make sense? I'm hoping we'll have a future where AI runs the workflow in the lab and all the scientists can play Dungeons and Dragons. That's kind of the future. I think it will be cool, but I know it's too futuristic. But that's the idea. And is there an implementation out? Have we done hackathons on it yet? Not yet. That's the plan. We are planning to do something in Q1 to see how we take some of our instruments and build this workflow. Would love to hear feedback. Makes sense? Does not make sense? That would be great.